Hello all, welcome to the presentation on a critical review of system-wide waste in construction industry. I'm Dr. Mahesh Babu Purushothaman, a lean expert, and my co-author is Dr. Jeff Seddon, a waste expert recognized by the United Nations. Construction industry is one of the oldest, prestigious, and essential industry that provides shelter to the people. The construction happens in 6 phases, starting with the planning and development, followed by the construction planning, then the pre-construction, procurement, actual physical construction, and then post-construction. Construction industry in New Zealand is a $30 billion industry, while it accounts for 23% of the waste with respect to material, labor, and time. What is currently being done? New Zealand construction industry is moving towards lean, where they are capturing 7 different types of waste, like the defects, motion, weighting, extra processing, transportation, inventory, and overproduction. So where and what influences these waste stages? Where can the waste happen? It can happen in any of the phases or probably all of the phases. However, most authors have recognized that the prime wastage factor is the design factor. Now, what are all the influences for the waste? A lot of authors have recognized a lot of factors. Primarily, many authors recognized underutilized skill, knowledge, the experience, talent or lack of innovation, and also recognized individual factors, the project team coordination, and organizational factors such as the culture of organization. There are certain other factors which many authors have recognized. For example, the method of construction, the storage method, human errors, technical problems, statutory compliance, unforeseen events, supervision, coordination, and the decision-making deficiencies. With that type of a background, the fundamental question for this research was that what are the different types of waste that organization needs to address. For this, we adopted a systematic review methodology, a 6-step process starting with the identification of keywords, followed by the development of exclusion and inclusion criterias, then the search engines to determine the quality of the papers, followed by development of an A, B, and C list. The C list was developed based on the construction keyword search, which resulted with 17,431 papers, which was reduced to a B list of 1,354 papers after going through the titles and abstracts. Then a further full-fledged A list was developed based on the read of the abstracts and the titles, which was from 90 literatures. This was followed by the descriptive and thematic analysis, and the paper includes 90 narrative inclusions. The systematic literature review revealed various types of waste. The primary was the lean waste, which we discussed earlier. Now, in addition to those 7 kinds of waste, health waste was identified by many authors. Similarly, the space waste was also identified by many authors. The next type of waste was the environmental waste, where the solid waste, spills, fills, and the gaseous substances emissions were recognized. The next important waste which was recognized by the authors was the information technology waste, and being an indispensable tool in the construction industry, the security threats, hardware defects, software bugs, and connectivity issues were also identified as waste. In an organization, Apart from the physical machineries and the processes, people form an important part. There are many decision making deficiencies that transform into a waste. One of those kinds of waste which people generate is the individual waste due to lack of decision or wrong decision making. There are so many factors like the self factors, situation factors, and the solution factor which influences the decision making and generates waste. The second type is the departmental waste. The departments have a lot of policies and procedures that would also generate waste. However, whenever the decisions cannot be taken within the boundaries of the department, the cross-functional teams are involved. The cross-functional teams also generate waste due to lack of trust, leadership, uniqueness, and it also accepts workable arguments which can also produce defects. The function which controls all the people is the HR function. The HR function can also generate waste. For example, an underutilized skill, people giving limited authorities and responsibilities can also produce defects. One of the waste measurement for HR function should be the absenteeism. While the HR function deals with a lot of people internally, there are external people like architects and contractors, consultants, and auditors, external certifiers who are involved in the construction. A conflict between architects and contractors are very common, which can produce defects. So such kind of defects produced by the external people can be classified as enterprises-wide waste. The entire setup of construction is a highly stressed industry, and this stress can cause a lot of wastages. So it is important to classify the stress waste, measure it, and then take forward to see how it can be solved. The last type of waste are the method waste, which involves the design waste, then the overhead waste, which is the supervisory kind of people generating waste, and the last one would be an eagerness and error waste, which could be classified under the method waste. Eagerness and error waste, however, cannot be avoided but can be measured and corrected for the future requirements. Now, these wastes can be classified into three groups, primarily the core construction, which would involve lean and environment, then the non-core construction, which will involve all the other waste except for the stress waste. The waste categories and construction phases, according to the systematic literature review, is mapped here. However, the current capturing is only on the lean waste, which accounts for 23% of waste in New Zealand. By definition, the waste in an organization is the excessive use or underutilization of men, machine, method, measurement, and material, or basically the 5M. The analysis revealed the 5M influence on various types of waste with respect to the outputs such as productivity, delay, accidents, resource utilization, and cost, which is mapped and shown here. Why should we identify the construction industry waste? If this study can influence you to understand the construction waste and a 5% saving is a result of that, that means it would add $1.5 billion to the bottom line of New Zealand construction industry. Some of the practical implications are that tracking these waste to compare estimated waste actual resources, reduction of waste, reduction of stress and environmental impacts, while the profitability and productivity would go up. Once a reasonable set of data is available, this can be used for budgeting and costing, which would give you a competitive advantage. Thank you very much. We'll be happy to take your questions on the private chat or through the group chats. Thank you very much.